Welcome to the second video on matrices data type in R programming. So in the last video we've seen how to declare a matrix and array and how to assign the different dimension names to matrices and arrays. So we have now declared an array M which has 3 rows and 4 columns. 3 rows and 4 columns. Suppose if I have to extract the second row, third column element, I use the syntax M of 2, 3. See, it is extracting the second row, third column element, that is 7. Okay. Suppose if you want to extract the entire second row, you can use the syntax M2, that's it. So it will extract the entire second row, that is 5, 6, 7, 8 is extracted. Suppose if you want to extract the entire third column, you can give M square bracket comma 3. So this will extract the third column, that is 3, 7, 11. And you can also extract a list of columns. You can give the options for the columns by giving M square bracket comma C1 comma 3. So this will extract the first and the third column. Okay, so it is extracting the first and the third column. Similarly, you can also extract a set of rows. So suppose if you are giving MC 1 comma 3, it is going to extract the first and the third row. Okay, so this is how we extract the different elements of a matrix. Suppose if you want to find the transpose of a matrix. So what is transpose of a matrix? Transpose of a matrix means interchanging the rows and the columns. The rows will become the columns will become the rows. So now what is there in M? In M you have 3 rows and 4 columns. Suppose if I am giving transpose of M, it will have 4 rows and 3 columns. The columns will become rows, rows will become columns. See here, it is having 4 rows and 3 columns. Okay, so this is how you find the transpose of a matrix. By assigning this syntax, you are declaring a matrix. The matrix is having 3 rows and 2 columns. The end row is 3 and end column is 2. This we have already seen. Now I am displaying M1 again. So I am declaring a matrix M1 with the 3 rows and 2 columns. So it has the values like this. And M2, another matrix I am declaring with 3 rows and 1 column, which is M2. And I'm displaying M2 again. So it is only having 3 rows and 1 column, only 1 column. Okay, so what we are trying to see here is we are going to combine the matrices M1 and M2 column wise. Okay, so that is the first matrix M1 has 2 columns and the second matrix M2 has another 1 column. We are going to combine these 3 columns using the function cbind. The function cbind will combine M1 and M2. So I am giving cbind M1 comma M2. So it is going to combine the 3 columns. See here. So it is combining the first 2 of M1 and the first column of M2, and it is showing the 3 columns. Okay. Similarly, we can also do a combine the rows of a matrix. Now I am creating the third matrix M3, which is having only 1 row and 2 columns. Okay, since M1 had 3 rows and 2 columns, I am going to create another matrix M3, which is also having 1 row and 2 columns. The number of columns should match if you are going to do a row bind. and the number of rows should match if you are going to do a column bind. That is the syntax. That is the syntax behind. Okay, so now I'm creating M3. So M3 is having one row and two columns. So now I'm running rbind. That is, I'm going to combine the rows of M1 and M3. M1 is having 3 rows and M3 is having 1 row with 2 columns each. So I'm combining these two. So now I'm having 4 rows and 2 columns. And there is also a way to convert a matrix into a vector. So for that the syntax is C of M1. So M1 is a matrix. If I am giving C of M1, it is going to convert that into a vector. That is, all the rows and columns will be made into a single row. That is a vector. See here you have 2, 4, 6, 8, 10, 12 as a single vector. Okay. So now let's see some mathematical operations on the matrices. So I'm creating a matrix M with 3 rows and 2 columns. M1, 3 rows and 2 columns. So M1 I'm running. So 3 rows and 2 columns is there. And M2 is another matrix with 3 rows and 2 columns. So M2 I'm displaying again. So you get the values. So now I'm going to sum up M1 and M2. So it is going to sum up the corresponding elements of M1 and M2. See, you are getting the addition of 2 plus 3, 5, 8 plus 11, 19, 4 plus 6, 10, 10 plus 1, 11, 6 plus 9, 15, 12 plus 5, 17. So similarly, this M1 multiplication M2 will not do the matrix multiplication, but it will multiply the corresponding elements. As it did for the plus symbol, it is going to multiply the corresponding elements. Okay, so for matrix multiplication the syntax is a little bit different. Let's see down the line. So now I'm again reinitializing the matrix M2 with the number of rows 2 and number of columns 2. Okay, so why I am declaring this is because for matrix multiplication, the number of columns in the first matrix should equal to the number of rows in the second matrix. So I am using M1 as the first matrix and M2 as the second matrix. M1 is having 2 columns, so M2 should have 2 rows. So I am now displaying M2. It is having 2 rows. Okay. So for actual matrix multiplication, we use the symbol percentage star percentage. Okay. So this will do the actual matrix multiplication. So I am doing M1 and M2 actual matrix multiplication. See the result. We have 54, 106, 72, 146, 90, 186. Okay. Similarly, we can also have the caret symbol, that is the power. We can raise the power of the matrix elements using the caret symbol like this. Suppose if I say M2 caret symbol minus 1, it means it is going to find the power of each element of M2. So M2 is having 2 rows and 2 columns, that is 3, 9, 6, 11. So if I say M2 caret symbol minus 1, it is going to take 3 to the power of minus 1, that is 0.333, and 9 to the power of minus 1, that is 0.111, and 3 to the power of minus 1, that is 0.166, and 11 to the power of minus 1, that is 0.0909, etc. Okay. Suppose if you want to find the inverse of a matrix, so we use the function solve. So this will give the inverse of the matrix. See, for the matrix M2, the inverse is given by solve of M2. Okay. So now we have seen how to manipulate, how to extract each row and column from a matrix or particular element from a matrix or a set of rows or set of columns from a matrix. We have seen how to find the transpose of a matrix. We have seen how to combine the columns of a matrix of two matrices, and we have seen how to combine the rows of two matrices, and we have seen how to convert a matrix into a vector, and we have seen the additional operation, multiplication operation, on matrices, and also the matrix multiplication using percentage star percentage syntax. And we have seen how to find the power of matrix elements, and also we have seen how to find the inverse of a matrix. Hope this will give you a clear picture on how matrices work on our programming. Thanks a lot for listening.